Hello viewers, in this lecture we will discuss about a MATLAB code that I have designed for the simulation of a financial system, which is a set of three nonlinear ordinary differential equations defined with the Liouville-Caputo differential operator, where the fractional order is of variable order type. Basically, in this research paper, authors have proposed three new numerical schemes. So today I will discuss with you the first one. And before I start my discussion, let me tell you that before you watch this lecture, I would recommend that you must watch the first part of this lecture number 9. Now, the numerical scheme with the Liouville-Caputo fractional derivative operator with variable order is given by equation 4.10 in this research paper, as now you can see on your screen. So in equation 4.10, you can see there are three equations for x, y, z, since the dynamical system is containing three governing equations. So you just need to focus on, for example, the first one. The second and third are merely the repetitions with slight difference in the notations of the dependent variables and the function. So look at this first equation in 4.10, and then I will show you the MATLAB code that is very easy to understand since I have used the same notations in the code as well. I have designed the code for both constant order and as well as for variable order. But before I jump into the code, let me tell you some very important and convincing points about variable order fractional calculus. So be with me. It will convince you that why you should study variable order fractional calculus, including, of course, the constant order fractional calculus. So now we know that the fractional calculus refers to the study of differential and integral operators of either real or complex order. One of the important application areas is the mathematical psychology, where the behavior of human beings can be modeled with the help of fractional order systems. Specifically, the way in which a person reacts to external influences depends on the experience he or she has made in the past. In other words, humans have memories. Fractional order operators are a very natural tool to model memory dependent phenomena. This is one of the most important characteristics of the field we call fractional calculus. Although the constant order fractional calculus can address some very relevant physical problems, it cannot capture important classes of physical phenomena where the fractional order itself is a function of either dependent or independent variables. As an example, take the reaction kinetics of proteins that has been found to show relaxation mechanisms that are properly described by a temperature-dependent fractional order. So now the fractional order is no more a constant. Thus, the underlying physics of the reaction kinetics changes with temperature. Hence, it is reasonable to think that a differential equation with operators that update their order as a function of temperature will better describe the protein kinetics. This simple example is enough to convince us that there exist classes of physical problems that would be better described by variable order operators. Hence, we need to understand variable order fractional calculus. These are the points on the slides I have collected from the two references that you can see at the bottom of this current slide. Now, let's move to the MATLAB code where I have taken the financial system given in the research paper by equations 3.1a to 3.1c. It has three differential equations. On line number 9, some important inputs are defined like step size h, initial value of the independent variable 0, that time integration interval 300 seconds, t, the interval, n is the iterations. Line number 11, initial conditions. Line number 13, constant fractional order, arbitrarily chosen by me, 0.976. Values of the parameters of the model are given in table 1 of the research paper. And now, starting from line number 18, 19, and 20, you can see that we have the three governing equations that constitute financial system given in the paper. Now look at the constant version of the Caputo algorithm that has been proposed in the research paper in equation 4.10, a new numerical scheme. So you can see that this is a very simple for loop that we need to understand the simulations of our financial system. So you can see on line number 26, this is the equation for the first dependent variable, which is given in the equation of the financial system. So if you compare this equation with the first equation of the scheme 4.10 in the research paper, then you will clearly understand that I have simply written the notations which are given in the scheme. I have written them in the MATLAB code. So it is not difficult to tally the terms given in the research paper. The only thing that you have to be careful about is these brackets used in this equation. After that, for y variable and z variable, you have to merely repeat the equation for the first dependent variable while taking care of this notation. X of 1 has to be used here, y of 1 will be used here, and z of 1 for our third dependent variable, including f1 notation for the first equation, f2 notation for the second equation, and f3 notation for the third equation. So this is for the constant version, and then you can plot it. After that, you have to simply write down the same scheme as I have written for the constant order. You have to write down in the same way for the variable order. The only difference will be now alpha, as you can see on line number 45, is defined by this equation, and this equation was given in the research paper for this alpha. So you can choose now any function for this alpha. So now alpha is no more a constant, rather it has become a variable. So you can see the same for loop I have written, including the alpha that is now a variable here. So you can look at this, that how I have changed alpha to this notation. And then finally I have plotted it. So it will take some time. That is why I have already plotted these two curves over here. So you can see that after the simulations complete, you will get this picture, the phase diagram with constant fractional order, and this one for the variable fractional order. I hope you have enjoyed the lecture. So finally, I would request you to like, share, and to subscribe my channel. Thank you so much for watching.